All right, IB AA SL2. Today we're going to cap off normal distributions by doing an inverse normal distribution. So let me tell you what exactly that means. This whole time we've been using like normal CDF to find from this spot to this spot, what would the probability be, which is the area underneath the curve. Today we're going to be kind of working backwards, and it's like if somebody gives you the area. So let's say that you know this area. Remember, the area underneath the total curve is 1, so that's why this works with probability so well. But like if they give you this, like if they say, for instance, that the probability is, I'll just make it up, like 0.75 or something like that. Terrible 5. The goal of today is to be able to find this spot, like what the cutoff is, how many standard deviations above or below, or what that z-score is another way to think of that. But you don't always have to turn it into a z-score because your calculator can do it without turning it into a z-score. So we're going to talk about both ways. But the main way we're going to do it is with this thing called invNorm. So you're going to hit second on your calculator and then hit distor. And then scroll down to the third one, which is invNorm. The way invNorm works, you might get that fancy menu that some calculators have, but if you're on an older calculator, it's just going to put this on your screen. What you do is put the area first that you're looking for, then the mean, then the standard deviation. So here, let me label all these. So yeah, that's the area you're looking for. And then this is, of course, your mean, and this is your standard deviation. The way inverse norm works, it always works from the left to the right. So let's make a note about that. So it always works from the left to the right. There's going to sometimes be questions where they ask you to find, this area over here, but then you have to do a little bit of trickery with invNorm to make it give you that area. So let's get into it. Let's do some examples. So first, given that z is like a normal distribution with mean of 0 and a standard deviation of 1, so we're talking z-scores here, we're going to use the calculator to find certain things. The first one is the probability. We're going to find this a value right here, given that the area underneath the curve is 0.877. So just a visual of what that looks like is that there's some point over here that we don't know where this area up to the curve, up to that spot on the line, is 0.877. The way you do that is put invNorm, then put 8.877, because we're looking for everything that's less than that, so it's working from the left, so we don't have to trick it on this one. The mean is 0, and the standard deviation is 1. And then you hit enter and you will get 1.16. Now you might look at that and be like, wait, Jolly, I thought you can't have a probability that's bigger than 1. That doesn't answer even make sense. Well, you guys, we're not finding the probability. We're finding the z-score, essentially. So what that means is that this spot right here, 1.16 standard deviations above the mean, so from negative infinity up to there, the probability of something being less than 1.16 is 0.877 when you have a mean of 0 and a standard deviation of 1. The next one is the probability that z is greater than a. So you really have to see that symbol, and that means there's some spot A over here. I'm just going to put it in an arbitrary spot. But now we're looking for the area above this. Well, we're given the area above it, which is 0.2. Now, invNorm does not work from the middle up to positive infinity. You can't force it to do that unless you got a fancy like really fancy calculator. So what we're going to do is say that the complement of 0.2, this entire side over here, is 0.8. So if we tell invNorm 0.8, it's still going to tell us this spot right here. So we'll go invNorm 0.8, mean of 0, standard deviation of 1. And then that one is 0.842. It's so close to the area, but that's just a coincidence. Let me double check that one. 0.801, copy paste. Yep, 0.842. All right, the next one, we're doing probability that, once again, greater than. So just a visual for you, that there's some spot that is bigger than the area above it is 0.55. So I'm kind of cheating by knowing that the spot is around here. Like, you don't know and arbitrarily know like where. Well, I guess we do know that it's somewhere to the left of the mean because 0.55 is more than half the distribution. So yeah, it's got to be to the left of the mean somewhere. I take it all back. Now, once again, that means this side is 0.55, and we can't get invNorm to do the right-hand tail, so we have to do the complement. We have to do 0.45. So invNorm 0.45, 0, 1. This is negative 0.126. So that's that spot right there. It's 0.126 standard deviations to the left of the mean. Part D. This one is interesting because it's a range from a negative A to a positive A, and we know that the area is 0.42. So just the visual on that, I'll pick like two arbitrary spots here, and we'll say that this area in between is 0.42. Now, we're going to use invNorm to figure out this area right here, or we're going to find that area and then use invNorm to figure out this spot. That spot will be symmetrical with the top spot, so if we get the negative value, we can get the positive one as well. Now, to figure out what the area is of this guy, in my brain, I think the easiest way is to take the whole distribution and subtract 0.42 and then divide it by 2 because there's two matching tails on either side. So 1 minus 0.42 divided by 2 is 0.29. So we can plug in invNorm 0.2901, and that gives us 0.553. I think, hold on. I'm deviating slightly from what the book is doing. 0.2901. Yeah, it's negative 0.553. So, because this is negative 0.553, that means A, both of those A's are equal to 0.553. Oh, we're going to start boxing answers now, Jolly? Yeah, it's fine, whatever. All right, that's the end of that problem. Another one. Given that X is normally distributed with a mean of 15 and a standard deviation of 3. Yeah, I realize that the book is weird, and so for some reason they keep putting a square on it for the variance, but trust, fam, that the standard deviation is 3 here. Now, we're going to find the value for capital X is less than lowercase x, 0.75. Now, the book turns this into a z-score. So here's what the book does. The book says, well, we can, if we know the z-score, we can use invNorm and 0 and 1. So they do x minus the mean divided by the standard deviation. And this equals 0.75, or no, 0.674. Let me just check their math. sorry, I'm messing up. At any rate, I don't think you really need to turn this into the z-score, because your invNorm you can set what the mean and the standard deviation are. So I think the best way to do this problem is just to go invNorm, the area is 0.75, the mean is 15, and the standard deviation is 3. And then it'll tell you what x is, and x is 17 in this case. So what that means is that if you were to draw a very bad normal distribution where the mean is 15, that if you were to go up to 17, that this area right here is 0.75. So this is 17. Yeah, I don't think you need to turn it into a z-score. Yeah, don't worry about it. All right, you guys. One last word problem. This one's about volumes of carton of juice, and they're normally distributed with a mean of 150 milliliters. So what that means is that, they shoot for 150, but some have a little bit more juice, some have a little bit less juice, and it's normally distributed. The bottom 5% of cartons are rejected for containing too little juice. We're going to find that minimum number for a container to not be rejected. This one is not too tricky because they said find the bottom 5%, and that's how invNorm works anyway. It finds the bottom whatever percent. So we'll just do invNorm 0.05, 5% as a decimal. The mean is 150, and the standard deviation is 5. Crunch that out, and you get 142. Well, actually, they rounded. I'm going to go exact. Well, not exact. I'm going to go 2 decimal points, because that's what I do. 0.05, 150, standard deviation of 5. Copy, paste that. 141.78. So, cartons must have more, because remember 141.78 is like exactly 5%, the bottom 5%. So to be able to not be rejected, cartons must have more than 141.78 milliliters. All right, you guys, that's it for invNorm and the end of our distributions chapter, I think. Oh, no, wait, there's one more assignment. Anyway, that's how you use invNorm.